Hi guys, it's me, Mr. Bertoch, your incredibly handsome science teacher. And in this video, I'm going to talk about specific heat capacity. My daughter recently carved a pumpkin for Halloween, and she wanted to make it as scary as she possibly could. And so, what she did was she carved a battery with low power, which I thought was funny. A battery has the capacity to hold a certain amount of energy, a certain amount of power, has a certain amount of capacity. And a larger battery has a greater capacity to hold power, and a smaller battery has a smaller capacity. So my watch battery, it's a very tiny battery, very small capacity to hold a very small amount of power. Fortunately, my watch doesn't use very much power. Whereas my fancy cell phone right here, yes, I have a dorky credit card thing on there, but this has a huge screen, and so it uses a lot of power. So it has to have a larger battery with a greater capacity. Capacity is a word that means the amount of stuff that something can accommodate. Okay, the greater the capacity, the more it can accommodate, the lesser the capacity, the less it can accommodate. So with batteries, we're talking about power. Well, we can also talk about capacity with heat. So objects, things have a heat capacity, which refers to the amount of heat or their capacity to store heat, the amount of heat that they can store before their temperature increases, before they become hot to the touch. Some substances have a much greater capacity. They can hold a lot more heat before they get hot, before they're hot to the touch, than other substances. For example, metal has a very low specific heat capacity or heat capacity. It gets to full charge, you might say, very quickly. In other words, it gets hot very quickly. I don't have to add very much heat to metal before it gets hot to the touch. The temperature gets high quickly. Water, on the other hand, has a very, very big, great specific heat capacity. Water can hold a lot of heat before the temperature rises. Think about it. If I take a bucket of water and I put it in the hot sun and I let it sit there all day, the water in the bucket over time, it's going to warm up. It might even get very warm, especially if the bucket is black and it's a hot summer day. Okay, it might get very warm, but it's not going to get warm enough to, say, boil. You're never going to get to the point where the water is going to be long enough or hot enough to cook anything. Okay, it's just going to be warm or even hot, but not really, really hot. But that's not the same with metal or with asphalt. Okay, if I put a metal slide in the hot sun and then I try to go down and I'm going to get burned potentially, or I could crack an egg and possibly cook it on the metal. And okay, the blacktop's gonna get really hot, and if I try to walk across it with my bare feet, I'm gonna be jumping around and going ow, 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 because it doesn't take a lot of heat to increase the temperature of something like metal or asphalt, because they have a very low specific heat capacity. They don't have a lot of, they're not big batteries. They can't store a lot of heat without the temperature rising. However, water has this ability to just keep taking in heat and taking in heat and taking in heat. It's not like the water isn't taking in heat. It is. It's taking in heat just like the blacktop is or the metal slide is, but it's storing it, and it can store a lot more heat before it runs out of capacity and it starts to boil, before it gets too hot, before the temperature gets really, really hot and it reaches its full capacity. So how does this impact specific heat capacity at let's say, for example, climate or weather? In an area that has a lot of water, such as, I don't know, where there's a lot of humidity and there's a lot of lakes and rivers, and maybe it's near the ocean, where there's a lot of water, the temperature, that water is going to have the ability to absorb heat all summer long. So the water in the air, the humidity, the water in the lakes, the groundwater, the near the surface, the water in the rivers and streams or the ocean, all of this water is going to, all summer long, it's going to be absorbing and absorbing and absorbing heat. And that heat is going to moderate the temperature. The result is going to be that the temperature in that area isn't going to get nearly as hot because the water is absorbing a lot of that heat. But what happens in winter? In the wintertime, the opposite happens. In that area with a lot of water, all summer long, I've stored all that heat like a battery. And now in the winter, when the sun isn't quite heating the earth as well, all of this extra heat that's been storing up all summer long starts to release slowly, because there's a lot there. It's like a battery that's got a big capacity. And so it's slowly, all winter long, it's being released. The rivers, the lakes, the air, the humidity, all of it is slowly, very slowly releasing its heat back out into the area. And the result is that it moderates the temperature again. The area doesn't get nearly as cold as it would otherwise get in the winter. Well, what about an area that's very dry, like a desert? I don't have a lot of water there. All I really have, I might have some, but very little. It's just rocks and things. Well, we already know that rocks have a low heat capacity. They can't store a lot of heat. And so what happens? In the summer, there's no water there to absorb the excess heat. And the rocks, the temperature of the rocks, they rise really, really fast. And so that heat radiates out, and it gets really, really hot very quickly. And so deserts can get very, very hot in the summer. And what happens in the winter? Well, there isn't a lot of water that's been storing up all this excess heat. And so in the winter, deserts tend to get much colder. And interestingly, the same thing happens in day versus night. Some of the most brutal places to try and survive if you're ever stranded somewhere is a desert, because the temperature difference just between day and night can be horrendous. In the daytime, it can get really hot because the sun heats up the ground, and the specific heat capacity of the rocks is very low. And so the rocks the temperature of the rock gets high really fast, and everywhere around you gets hot. And then in the night, the rocks cool down almost immediately once the sun goes away, and it can get really, really cold. Even in the summer in a desert, it can get really cold. And so I can get these huge temperature swings in a desert. Whereas in a place with a lot of humidity, the temperature is very moderated. The swings between day and night are much lower because there's all of that water that's absorbing the heat in the day and letting it out at night. And same with summer versus winter. The change in temperature is much more moderate. I grew up in a place called Utah, which was a desert, and we got very cold. Utah is famous for skiing. It's got the biggest ski resort in the world in Park City, and we get a lot of, it gets very cold there in the winter, but it also gets really hot in the summer. It gets up regularly in the summer, up over 100 degrees. And in the winter, it regularly gets down into the low teens or even below that. Okay. I now live in a place called West Virginia, which is not a desert, it's a forest, and it gets humid here. There's a lot more water. We have this huge river just down the road from me called the Kanawha River, and there's a ton. There's lakes and streams and rain all the time. All of this water moderates the temperature because of the specific heat capacity of the water. And so the result is in the summer, we're much cooler here than in Utah. We get up into the 80s typically. And in the winter, we get down to the 40s, but a lot of the winter tends to even be in the 50s, 40s, 50s. So it's much less of a swing because even though we're at similar latitudes, because of the difference in the amount of water. Water has a moderating effect because of its specific heat capacity on weather and on climate, and even and the difference between day and night on the temperature that we get. So remember, capacity refers to the amount of stuff that something can hold. If it's a battery, we're talking about electricity or energy. If it's heat, if it's specific heat capacity, then we're talking about heat. Water has a high specific heat capacity, as do some other objects like wood. But other objects like metal or rock tend to have a very low specific heat capacity, can't store a lot of heat in them. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos also in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.